Have you ever wondered about the power behind India's space missions? The engine that propels India's dreams into the cosmos? Meet the Vikash engine, a marvel of Indian engineering that has been the heartbeat of many space missions. Our journey begins in the 1970s, when the Vikash engine was conceptualized and designed. The Liquid Propulsion Systems Center, a pivotal wing of the Indian Space Research Organization, or ISRO, was the cradle where this brainchild was nurtured. Vikash, named after Vikram Ambalal Sarabhai, the father of India's space program, is a family of hypergolic liquid-fueled rocket engines. The design of these engines was inspired by the Viking engines, with the addition of a chemical pressurization system. The early versions of Vikash engines utilized some imported French components, which were later replaced by domestically produced equivalents, marking a significant stride towards self-reliance in space technology. The Vikash engine plays a pivotal role in powering the second stage of the Polar Satellite Launch Vehicle, or PSLV, the boosters and second stage of the Geosynchronous Satellite Launch Vehicle, Mark 1 and 2, and the core stage of the LVM-3. The propellant loading for Vikash engine in these launch vehicles ranges from 40 tons in PSLV and GSLV Mark 1 and the second to 55 tons in LVM-3. In 1974, a pivotal agreement was made with Société Européenne de Propulsion to transfer Viking engine technology in return for 100 man-years of engineering work from ISRO. A little over a decade later, in 1985, the first engine built from the acquired technology was tested successfully by Nambi Narayanan and his team at ISRO. They named it Vikash. The engine uses about 40 metric tons of unsymmetrical dimethylhydrazine, or UDMH, as fuel and nitrogen tetroxide as oxidizer. It produces a maximum thrust of 725 kilonewtons. An upgraded version of the engine has a chamber pressure of 58.5 bars as compared to 52.5 bars in the older version and produces a thrust of 800 kilonewtons. This engine also features the capability of gimbaling or pivoting to steer the vehicle's flight path. In 2018, a 6% increased thrust version of the Vikash engine was developed, demonstrating its prowess in the GSAT-6 launch second stage on March 29, 2018. This upgraded version is set to power the first stage boosters on future missions. In summary, the Vikash engine, a product of homegrown engineering brilliance, has been a cornerstone of India's space missions. From its conception in the 1970s to its continuous upgrades and improvements, the engine has been a testament to India's technological prowess and ambition to reach for the stars. And as it powers into the future, one can be sure that the Vikash engine will continue to propel India's dreams into the cosmos.